Okay, chapter 8 is dealing with right triangles. Oops, I forgot to change something up here. Let's do this and do this. Okay, so we're talking about right triangles. Before we start talking about right triangles, though, I want to show you one little thing. It's pretty important for what we're going to do this lesson. Right? And it's called the geometric mean. Geometric and then mean, M-E-A-N. If you remember from algebra, pre-algebra, regular math, whatever, the mean meant the average. Okay, this is not exactly an average. You're not just going to take the two numbers I give you and just add them up, divide them by 2. This is a little different. This is called the geometric mean. You're not really going to have to completely understand why we call it the geometric mean or what you're really finding. What this is going to do, this is a tool to help us find some missing sides of a right triangle that we wouldn't have been able to solve for before. Any of you guys taking notes? You're just sitting back, relaxing? Okay. Let's take some notes on this. So this is geometric mean. This is how we, here's the question that they're going to ask you, and I'll show you how to set the thing up. It's going to say, find the geometric mean. I'll just shorthand it. Is that all right? GM. Find the geometric mean between these two numbers. So I'm going to give you two numbers, and you're going to find the geometric mean between those two numbers. And I'll use the same numbers that I used in the other class. Worked out pretty easy. Between 2 and 5. So here it is. Find the geometric mean between 2 and 5. And again, don't worry so much right now what you're actually finding. Just know how to do it. All right? Just know how to find the geometric mean. Because, and to tell you the truth, because I'm not really sure how I can like explain, because I'm not sure myself what that really means. But I do know that we can use this to find missing sides of a triangle.
It says find the geometric mean.
Between 2 and 5. So here's what we do. We just had a whole entire chapter where we did ratios and proportions and stuff like that. Remember all that stuff? Yeah, it was just Friday. Okay, he took a test on it. So we're going to actually set up a proportion again. All right, so we're going to set up a proportion. These are fraction bars. Okay, I'm going to have a number over another number, a number over another number. These are fractions, and there's an equal sign in between them. So that means it's a proportion. When you have a ratio set equal to another ratio, or a fraction equal to a fraction, that's a proportion. When it says find the geometric mean, we're going to actually use x to represent the geometric mean. So that's where x is going to go. But it's not just going to go there. It's going to go actually in 2 places, which is kind of weird because we don't usually have x in 2 places here. But x will go here, and x will go right here. Notice where they are to each other. They're diagonal to each other. Everybody see that? So that's what we're trying to find. You're paying attention, right? So we're finding the geometric mean between 2 and 5. So this is the geometric mean. I just used x as a variable. It doesn't have to be the letter x. Okay, it could be any letter at all. Okay, take that off your head, please, because you're just disturbing everybody and disturbing me too. So x is the geometric mean, and it goes right here and right here. Now notice, this one's on the top left, this one's on the bottom right. If I wanted to, I could put it on the top right and the bottom left. It doesn't matter, as long as they're diagonal to each other. I would not put the x's on top of each other. You see that? So the x's have to be diagonal to each other. So when it says find the geometric mean, this x right here is considered to be our geometric mean. That's what we're solving for. Now it says find the geometric mean, which is x, between 2 and 5. Now, wild guess. Where do you think the 2 and 5 are going to go? Right, diagonal to each other as well. Right, in the other 2 spots, right? So the 2 and the 5 go right here. It's as easy as that. It's not that hard. You'll actually have a problem on the test that'll look just like this. It may not be those numbers 2 and 5, or it might be. I don't know. But there'll be a problem on the test that will tell you exactly this. It'll be number 1 on the test. I promise you. The first problem on this test, when you have it, when we finish chapter 8, it's going to say, find the geometric mean between these 2 numbers, whatever it is. I give you any 2 numbers, couldn't I? All right, I just said 2 and 5. So this is how you would set it up. You'd put your little fraction bars equal in between, put an x on at the top of one, and put x on the bottom of the other one. Everybody see that? So they're diagonal to each other, and stick the 2 and the 5 or whatever numbers they give you in the other two spots. Now what we can do is we can actually solve for x. Find what x is. So what do you think? What's our process here to solve for x? Cross multiply, exactly right. We did a whole bunch of that stuff in the last chapter, so you should be used to it now. So we cross multiply. I like to do the x's first. So what is x times x? Is it 2x? A lot of people say that. It's x squared. If I multiply x times x, that's equal to x squared. Do you remember the rule? In Algebra 1, you learned these things, didn't you? When you multiply and you have exponents, what do you do with the exponents? You add them up. Do you remember doing that in Algebra 1? Okay, so that's the rule right there. So x times x is x squared. It's not 2x. Watch this. X plus x is what? 2x. Okay, 1x plus 1x is 2x. But when I multiply them together, I add the exponents. So it's x squared. Everybody got that? Okay, so x times x is x squared. Equals, what are we going to do now? Multiply 2 times 5. And what's 2 times 5? It's 10. So is my answer 10? Is that the geometric mean? No, it's not. What do we have to do to get rid of that squared right there? Say it. Square it? You sure? Square root it. Right. Take the square root of both sides. The root, the square root, and the square, okay, cancel each other out basically. All right. So we square root it. So we square root this side. What do we have to do to the other side? Square root the other side. So look what happens. What does that square root do to the square?
X.
Cancels it out. So what are we left with? X. Now, what do we do with that? Can we simplify that? Nope, just keep it the square root of 10 and circle it, and then you're done. That's all there is to find the geometric mean. It's just setting up a little proportion, cross-multiplying, and then just solving for x, getting x by itself. That's all there is to it. It's not that hard at all, is it? All right. Let's do another one. What if I said find the geometric mean between I don't know. This number worked out pretty good in the last class. We'll use the same numbers. Between 4 and 7 this time. Alright. Tell you what, let's just a little change of pace here. Alright, you go ahead and do it. Should probably take about 10 seconds. Literally. First of all, you set up a proportion, right? So set it up. Don't just do it in your head. Set it up. So what goes here and here? X. That's the geometric mean. That's what we're solving for. Okay? It says,
always like that?
Yep. It says find the geometric mean. That's where the geometric mean goes. Now, there's another option, but it's really no different. What's the other option here? I could put X where? On the bottom left and the top right. As long as they're diagonal to each other, it doesn't make any difference. You're still going to get the same thing. All right. I don't know. For some reason, I just like putting it on the top left and the bottom right. That's all. Now, what goes here and here in these two empty spots? 4 and 7. That's it. Simple, isn't it? Yeah. If you know the little formula that we use for geometric mean, it's not hard to plug in the stuff. If it says find the geometric mean, we'll call it x. We don't know what it is, so we put an x here and an x right here. Between what and what? 4 and 7. So you put those two numbers right here, you're good to go. Well, you got to solve, right? That's what we did up here. So x squared is what? 7 times 4 is? 28. What do we do to get rid of that square? Square root it, and there it is. X is equal to what? Square root of 28. That's not the same as 28, is it? Okay, it's a different number than 28 is. In fact, if you want to, you don't have to do this, and to tell you the truth, I would rather you keep the answer just like that. Just like we did over here. Notice what I circled. Did I put that into a calculator? I didn't, did I? Okay. Did I put that into a calculator? No, I didn't. Okay. Now, could you? Yeah, I guess if you wanted to. But I don't really see any benefit at this point. Right now, I really don't see a big benefit to doing that. But I'm going to do it anyway because I know you guys love your calculator. So, watch. The square root of 28. So, on this calculator, I hit second function and this. Do you see how that little square root is in yellow? That's why I hit second function. So it's the square root of what? 28. Now, if you have a little TI-30 XA or whatever they call that thing, just a regular scientific calculator, you don't hit square root first. You hit 28 first, then you hit the square root button. And in fact, on your little TI-30 the square root button actually is an actual button. You don't even have to hit the second function, okay, on a lot of your calculators. All right. So what you would do, you'd hit 28, then the square root button, and then bang, you don't even have to hit equals. It'll automatically give you your answer. But on this calculator, you got to hit square root first, then you put 28 in, and then you hit the enter button or the equals button, and there you go. Let's round it to 1 decimal place. What would that be if you round it to 1 decimal place? 5.3. Is it exactly, oops, that's not what I wanted to do. Is it exactly 5.3? Is it? It's exactly 5.3? No, it was 5.29 or something. So watch, I put a little squiggly equal sign and put a 5.3. What does that mean? This little squiggly equal sign. It's approximate, okay? It's an approximation. This right here is an exact answer. Now, for your class, I'm not going to be really picky on this, all right? But I'm going to warn you. You might have done a little bit of this in Algebra 1, and I'm sure you're going to do some of this in Algebra 2, where you have to take this and simplify this radical. This is geometry. I'm not really here to teach you that. In the honors class, I did go through it, but I was even easy with the honors class. Because at first I said I was going to make them simplify it, then I was seeing people really struggling with it, even though I explained it 100 different ways and times. So on the test, I allowed them just to keep it like this. But in Algebra 2, you're going to want to know how to simplify these things, but I'm just not going to take the time to do that right now. All right, so you could write it either way. What would I prefer? I would prefer the exact answer. See, that's the exact answer. This right here is approximation, isn't it? It's approximately equal to 5.3. It's not exactly 5.3, but this is exactly the square root of 28. All right, we good with the geometric mean? That's pretty easy, isn't it? You say, well, what did I just find? What is that 5.3? Well, it is, look, it is between 4 and 7, isn't it? Is it exactly halfway between 4 and 7? Now, what would be exactly halfway between 4 and 7? 5.5, right. 5.5 would be exactly between. This is not 5.5, is it? It's close to it, but it's not. So this number right here doesn't mean it's exactly between, but it is going to be between 4 and 7. It's going to be somewhere in between. Okay, doesn't mean it has to be halfway between. It's going to be somewhere between 4 and 7. All right, you with me on that? All right. Why do we even care what this geometric mean is? What am I finding? What's the significance of using the geometric mean? Well, I'm glad you asked that question because I've got an answer for you. Look, what I'm going to do, remember what I said what this whole chapter is about? What did I say right at the beginning? It's about right triangles. I haven't even talked about a right triangle yet, have I? All right. That was just to lead us into what we're going to do right now, okay? It was just a little bit of information to be able to solve for what we're going to solve for right now. I'm going to draw a right triangle. I'm going to kind of draw it off on its side. For some reason, they like drawing it like this. So I'll draw it like this. About right there. All right, so I put a little right angle right here. That's a right triangle. Everybody with me? Now watch what I'm going to do. Let's do this in a different color. Let's go yellow. What I'm going to do is I'm going to drop an altitude from this right angle. What does that mean, drop an altitude? Do I go to the midpoint? Do I bisect the angle? What am I doing? I go what? Straight line. Well, that's a straight line right there. Perpendicular. Thank you, Joe. We've been talking about this all year. Use the right word. It's perpendicular. Okay? It's perpendicular to this whole side. Look at this whole side right here. What do I call that whole entire side? It's opposite this right angle, so what do I call it? Call it the hypotenuse. Is anybody paying attention? My gosh, you got the, what do you call it? The, I can't even remember it. No. The, I'm trying, I had it off the top of my head, now I can't even think of it. See what you've done to me? All right. You got the attention span of a flea, all right? That's what I like to say. Not ignorant, I'm just telling you what it's like. You should see your faces when I'm up here. It's like everybody's off in the Wonderland or something. I don't know what's going on. So let's just pay attention. It's not that hard. My gosh, I've seen and been around teachers that are much more boring than what I'm being right now. Look, this should be hush, don't talk, please. Listen to me. let's pay attention and focus, okay? It just takes a little self-discipline is what it does, okay? You're not disciplining yourself. You're not making yourself pay attention. In my other class, I saw a kid shaking it off. He was starting to nod off, and he's shaking it off. That's self-discipline. That's making himself pay attention to what I'm doing, okay? If you're just laying around and not taking notes on this, talk. This is not a two-way conversation. Did you know that? It's one way. Let's take a look at this side right here. We're going to call this side A. I'm going to call this side B. And I'm not going to call this whole thing. We'll just call this, we're not going to call this anything. I'm going to put some numbers in here and then we'll figure out what this is. Let's use those same exact numbers that we used for the first geometric mean. Let's call this little length 2 right here. Now the 2 is not the whole entire thing. The 2 only covers from here to where this altitude hits right there. It's a segment of the hypotenuse. And I'm going to refer to it that way quite a bit. This is one of the segments of the hypotenuse. Well, the other part of the hypotenuse has a length 2. We'll call it 5. Okay, I'm just making these up off the top of my head. We'll say that's 5. What would the whole thing be then? It'd be 7, right? Because this is 2, this is 5. They all add up to be the whole thing. I have 3 different situations here. And let's put an H for this length. H for height, okay? Because this is the height or the altitude of this big right triangle. Let me show you a couple things. This right here is a geometric mean. Remember how we said X was a geometric mean? Well, this is actually a geometric mean between 2 numbers. Well, between which numbers? I've got 3 numbers here. A is a geometric mean between what 2 numbers? Well, I'll tell you in a second. B is also a geometric mean between 2 of these numbers. And H is also a geometric mean between 2 of these numbers. Now, I could sit here and go through and show you why this is the way it is. And if you really, really want to know, they go through it in the book. But basically, we have 3 triangles. We got this little one right here, this medium-sized one, and the whole big one right here. All 3 are right triangles. And they actually are all 3 similar triangles. So you got proportional sides and all that kind of stuff. I'm not going to go through the whole reasoning why this is true. I'm just going to show you what it ends up as being, okay? Because I just think that'll confuse you more than anything, okay? What we're going to do, all 3 of these things that I circled are geometric means. Let's start with H, this altitude right here. So it's a geometric mean. Remember, I said all 3 of these are geometric means. So if I say this is a geometric mean, I set up my proportion. Where am I going to put the H? On top and on the bottom diagonally to each other. Everybody see that? So H is a geometric mean, so I'm going to put it here and here. Now, you don't know between which 2 sides, but I'm going to tell you right now. This altitude is the geometric mean between the 2 segments of this whole hypotenuse. So what are the 2 segments of this hypotenuse? 2 and 5, that's right. So I put a 2 here, and I put a 5 here, and that's the geometric mean between the 2 segments of the hypotenuse. We'll solve for this in a second, okay? You know what we're going to do. We already did this once today, didn't we? Cross multiply. So off the top of your head, what do you think H is going to equal?
10 squared.
Square root of 10, okay? Square root of 10, not 10 squared, not 10, the square root of 10. Everybody see that? That's what H is equal to. We would have never been able to find this before knowing about geometric mean, all right? Let's do A. A is also a geometric mean. Right? So I put the A's diagonal because A is also a geometric mean, but between 2 different numbers. I'll tell you. It's between the whole hypotenuse. What's the whole hypotenuse? And the segment of the hypotenuse that's closest to side A. I got 2 segments. I got 2 and 5. Which one's closest to A? 2 is. So I pick what? 2. So A is a geometric mean between the whole hypotenuse and the segment of the hypotenuse that's adjacent or closest, or next to, I should say, that side A. Everybody see that? All right. B is very, very close to A. So I bet you can figure that out. B is also a geometric mean between what and what? It's very close. 7 and 5, exactly right. The whole entire hypotenuse and the side or the segment of the hypotenuse that's adjacent or next to side B. So I put a 7 and a 5 right there. Those are the three things that you have to know, that you have to basically memorize, I guess, or just know how to set it up, right? The altitude is the geometric mean between the two segments. See how it's broken up into two parts? So this is the geometric mean between these two parts right here. A is the geometric mean between the whole hypotenuse. Why do I keep calling it the hypotenuse? Because look, it's opposite the what? The right angle, okay? So A is the geometric mean between the whole hypotenuse and the segment or the part of the hypotenuse that's closest to A, which is 2. So 7 and 2. B is the geometric mean between the whole hypotenuse, 7, and the part of the hypotenuse or the segment of the hypotenuse that's adjacent or next to B. So between 7 and 5. Everybody see that? So just kind of remember that. H is the geometric mean between 2 and 5. A is the geometric mean between what? 2 and 7. And B is the geometric mean between 5 and 7. Okay? They're not always going to be this easy. This is about as easy as it gets. Sometimes they're going to make it a little bit more complicated. Sometimes this won't be a variable. Sometimes they'll give you that number. All right? They might say that geometric mean is 6. And so instead of saying B is the geometric mean, what if that was 6? Completely different from this problem right here. But I would put the 6 here and the 6 here. Does that make sense? All right, so if I knew that side, it's still a geometric mean, so I still put it diagonally. All right, you'll see some of those on the worksheet that I'm going to give you today. All right, so what can we do here? Let's change colors. Getting tired of that. Let's go to this color right here. So what do? Cross multiply, right? We did this once already today, this exact numbers. So h squared equals 10, and then take the square root of both sides. So h equals the square root of 10. If you want, you could put that into a calculator. But look, I would accept that. Why bother taking a chance making a mistake, right? Putting it into a calculator when you can just keep it like that. I'm perfectly fine with that right there. It may not make a whole lot of sense to you. What is the world's the square root of 10? I don't know. You could put it in a calculator if that bothers you. You should be able to kind of figure it out of the top of your head. The square root of 10 is close to what? The square root of what? That comes out nice and even. Well, not the square root of 3. The square root of 9, which is 3. Okay? So square root of 10 is close to the square root of 9. So square root of 9 is 3. So square root of 10 is probably just a little bit what? A little bit higher. And we figured it out earlier. It was what? Like 3.2 or something like that? Yeah. Okay, we were right. Let's do this one. Let's cross multiply. A squared is equal to what? 14. So A is what? Square root of 14. That's right. And you just circle it. That's our answer right there. You can't do anything else with it. You could put it into a calculator if you really, really wanted to, but we're not going to. Let's do this one. Cross multiply. What do you get? B squared equals 35. B equals what? Square root of 35. Look at that. Now you've got all three of these lengths right here, and we would have never been able to do that before today. Because look, they only gave you one side of a right triangle, didn't they? What if they gave you two sides of a right triangle? You could always find the third side by what method? We've talked about this earlier in the year. What is it? Pythagorean theorem, that's right. Okay, we're going to talk about this in the next couple of days too, Pythagorean theorem. But yeah, you already know Pythagorean theorem, but the only way we can use Pythagorean theorem is if I know two sides of the right triangle. I don't know two sides. And some people look at this, well, yeah, you do. You know 2 and 5. But are they two different sides of the right triangle? No. They're just part of that one hypotenuse, aren't they? All right? So there was no way we could have figured out this before, and now, by knowing this stuff, we could figure it out. All right? So that's why geometric mean is important. I mean, you probably looked up here when we did this stuff, and we're like, okay, big deal. So you got square root of 10. What in the world does that mean? All right? And down here, big deal. You got square root of 28. What in the world does that mean? Well, the geometric mean really helps in finding missing parts of a right triangle. So again, this whole entire chapter is about right triangles. This is the first part, is geometric mean. Now, there's not a whole lot of situations where this shows up because you have to have a right triangle and you have to have an altitude drawn to the hypotenuse. But if you do have that situation and you know some lengths, you can find some missing sides right here, right here, and right here. Okay? So to me, I think that's pretty interesting. That's stuff that we weren't able to do before, and we can find missing parts, and that's what geometry is about, right? Finding all the missing sides, finding the missing angles, and all that kind of thing. That's what we're going to do right there. All right, enough of that. That's section 8.1, and I'm going to give you a worksheet, and it's going to deal with this stuff right here. So hopefully you have notes on it. These three things right here, this, and this, are the most important things that we did the whole entire day. That's what it all boils down to. If you can set this one up, and this one up, then you should easily be able to solve for your lengths. Okay? All right. So we'll do the worksheet tonight. Tomorrow we'll go over it, and I might even do some more on this stuff, just depending on how well I think you got it last night. All right, so that's it.